Good evening, everyone. I'm Mahaswi Ganipisetty, a second year CSE undergraduate at IIT Bombay, and I'm currently working on this project under the guidance of mentor Sridhar. Today, I'll be presenting my work on coral reef bleaching risk modeling, focusing on the Arabian Sea and Bay of Bengal. Coral reefs are often referred to as the underwater gardens. Beyond their ecological importance, they support a large fraction of marine life by providing habitat, shelter, breeding, and many more. As a result, the condition of coral reefs is closely linked to the condition of the surrounding marine systems. When reefs undergo bleaching, the effects are not restricted to the corals themselves. Habitat quality begins to decline, which can influence biodiversity, fisheries, and other ecosystem services too. Several large-scale bleaching events, including those happened in India during 1998 and 2016 demonstrated these impacts. These events highlighted the need to continuously assess these conditions rather than relying solely on occasional field observations. As a result, many organizations and several reef monitoring programs now continuously keep track of reef health and bleaching activity. However, the importance of reef status information extends beyond reef monitoring itself. Since many marine species depend directly or indirectly on reef habitats, researchers studying fisheries, biodiversity, ecosystem dynamics, and conservation frequently rely on information about reef condition to better understand the systems they are investigating. Therefore, improving our ability to predict bleaching risk can provide more reliable reef status information for monitoring programs as well as researchers working on marine ecosystem. Several bleaching risk models already exist, and many of them achieve reasonably good performance. Therefore, the objective of my work is not simply to build another prediction model. Instead, I'm interested in investigating a few questions that remain less explored. My first question is whether whether uh, beyond the commonly used thermal stress indicators, can we use oceanographic variables providing meaningful additional predictive information? Existing approaches rely heavily on FST and DHW. I would like to examine whether incorporating factors such as pH, chlorophyll concentration, turbidity, salinity, and other variables leads to a significant improvement in predictive performance. The second question concerns a regional variability. The Arabian Sea and Bay of Bengal are environmentally distinct systems. This raises the question of whether a single model can represent both regions or whether region-specific models are more effective. To investigate this, I plan to compare a unified model against separate regional models and evaluate their respective performances. The third question is motivated by an observation frequently reported in the literature. Reefs exposed to similar thermal stress do not always exhibit similar bleaching responses. This suggests that there may be additional location-specific characteristics influencing bleaching behavior. I would like to investigate whether such effects can be represented through a resilience-related factor and whether incorporating this information improves predictive capability. To address these questions, first conducted a literature survey to identify environmental variables that have been associated with bleaching. Based on this review, I selected factors such as pH, chlorophyll concentration, turbidity, salinity, SST, and DHW. Currently, I'm in the data collection stage. Data are being gathered from sources such as NOAA and other environmental databases. To conclude, coral reefs are not only important ecological systems but also a critical source of information for researchers, monitoring agencies, and conservation programs. Through this work, I aim not only to improve bleaching risk prediction for the Arabian Sea and Bay of Bengal, but also to better understand the environmental, regional, and related factors that influence coral bleaching. Thank you.